So now we're going to talk about the commercial production of radioisotopes. Now, it's very important that you understand here that we are not necessarily talking about transuranic elements. So here, generally, we're going to be talking about Z less than or equal to 92. Not exclusively, you can make the other ones, but this is where we tend to be focusing on, because the commercial radioisotopes tend to be much smaller than uranium. Alright, so what is a radioisotope? First, it is a radioactive isotope, which means it's going to decay over time. Okay, so the first way we can do this, well, there's two ways that we've talked about, is neutron bombardment. Okay, so we're going to bombard with neutrons in a nuclear reactor. Now, we can use neutrons from nuclear fission reaction, so this is what's happening in the nuclear reactor. One example is Cobalt-60. Now, Cobalt-60 is a gamma emitter. That's what that is. That sort of weird Y-shaping thing is your gamma. It's a gamma emitter. It's got three uses that we'll talk about. We're going to talk about two today, and in another video we'll talk about the big use for it. It's used to sterilize medical equipment, and it's also used for radiography, for imaging, for radio images. Now, it can also be used to treat cancer, and we'll talk about that in a little bit, or in another video. The reaction looks like this, though. So its neutron bombardment starts down here. So you put in Cobalt-59, which is a stable isotope of cobalt, and then we hit it we neutron bombard it, and we get Cobalt-60. Now, this Cobalt-60 will then decay further, and it will decay. We won't go to what it's going to decay to. That's for time for another video. It will decay, and it will release both beta particles and gamma radiation. Now, another way to do it is using a particle accelerator, and this is called nuclear fusion. Fusion because we are joining two elements together. So basically, you can do this several ways. You can fire protons, we can fire deuterons, which are deuterium atoms or nuclei. So you can fire deuterons or alpha particles at a target element. We can also fire, if we want to make transuranic elements, we can fire heavy nuclei at each other. But to make radioisotopes for commercial uses, we'll fire protons, deuterons, or alpha particles at a target element. One example of this is iodine-123. It is also a gamma emitter, and we use it for thyroid imaging. The iodine is taken up by the thyroid, like this is absorbed by the thyroid, and then you can hit it with, you can use it to make an image of how big the thyroid is, where the blood is pumping in the thyroid, etc. And we make it using xenon. So you've got your xenon here. The xenon is then, so the particles of xenon are then absorbed have protons, that's a proton, have protons bashed into them in a particle accelerator, which is extremely cool. When that hits it, that will give us iodine. Now, what's crazy is that as this particle hits this proton, your natural instinct might be think that this Z is going to go up. But what actually happens is it goes down. And the reason it goes down is you get two neutrons ejected from it, but you also get beta decay. And this beta decay means that, so you've got an extra proton there, and two of those protons, so one of these protons plus this one here, will decay into forming neutrons, and they will release electrons. And that's pretty rad. So that's how we get, that's how we use nuclear fission to make a commercial isotope, radioisotope. So we bash them together, and then it'll undergo beta decay, as well as releasing some neutrons because it's too heavy. Alright, hope that made sense. See you next time.